Welcome everybody to another video. Today we're going to be having a look at the IGCSE Chemistry notes, and this is the first video in the chemistry syllabus. So basically there are about 14 topics in the chemistry IGCSE syllabus for 0620, and so in today's video we are going to be having a look at chapter 1, which talks about the particulate nature of matter. Now there are going to be several videos talking about the several topics that are needed in the IGCSE syllabus for the code 0620. So if you're doing the same syllabus, I'll be making videos on each chapter, and therefore, you can revise better. So we're going to be starting with Unit 1 or Chapter 1, the particulate nature of matter. Now, basically, the particular nature of matter simply just talks about solids, liquids, and gases, and it's a quite broad topic, and you've been learning it for quite some time. So here's the table of contents that you need to know. In today's video, I'm going to be having a look at the core and the supplement. Okay, that means if you're doing the core paper, you only need to focus on the chapters or the topics where it's written core, and if you're doing the paper 4, for example, you'll have to know everything that is in this video. But again, if you're doing the paper 3, then you only need to know the core section. Okay, anyway, today we're going to have a look at all these topics that you see, and I assure you that all these topics that you see, all the questions come around them only. Like basically most of the questions that are coming in the IGCSE exams are always revolving around these several topics. So we're going to start with the first topic, where we're going to have a look at the differences, or in terms of properties, between the solids, liquids, and gases. Now you've been doing this for quite a long time, and also when you start chemistry, this is the first thing that you do. Usually this is the first thing that you do, and in several other topics, solids, liquids, and gases are really important. So let's start with this several topic. So right here we have a table where we are given a solid. I'm just going to remove my pen tool. So here we have is a solid, okay, a liquid, and a gas. Okay, so you need to know the properties of each of the following and how they differ from each other. For example, let's begin with solids. Okay, from solids you can see it has a definite shape. A definite shape simply just means it has a similar shape, a same type of shape. That means that if I put it, or I change the location of it, it will have the same shape. If I do anything to it, it will have the same shape. If I move it around, it will have the same shape. It has a definite shape. With the liquids, as it's telling us here, is that it will take the shape of the container. So a good example is, for example, water in a bottle. If you've noticed, if I take that water from the bottle and put it into another container, the water will take the shape of the container. And that's how we can differ it from solids. Solids, it'll have a definite shape. It wouldn't change. But for the liquids, it will take the shape of the container. And then with gases, it's saying there's no definite shape. That means that it will go a random movement. You cannot determine the shape it will make. If I put it in some other container, you will not, define, or you will not find the definite shape that it forms, because it is a gas. So you go, that is the first row. The next row talks about the volume. When we're looking at the volume, for the solids, we're saying that it has a definite volume. A definite volume is the same thing as a definite shape, but this basically means in terms of volume, it is the same. For liquids, it is the same because it does not change, okay? If I shift that water from the bottle to the container, the liquid inside it, the volume inside it will be the same, okay? Only the shape changes, but the volume remains the same. And when we're having a look at gases, it will occupy as much space as possible. So that means, for example, if I put a gas in a room, it's going to spread. It's going to spread. And later on, we're going to get to know about something called diffusion. And I'm sure you've heard of it. Diffusion is the spreading of the gas, or the spreading of something, the spreading of a substance. Okay, so gases will occupy as much as space. That means that the volume will become bigger. Okay, but for the liquids and solids, it will stay the same. Then we have a look at compression. Now, this is a very frequent asked question, compression, okay? Solids cannot be compressed. Solids cannot be compressed, and I can back that answer with because they have a definite shape, okay? Because they have a definite shape, they cannot be compressed. But with the liquids, they can be compressed, but just slightly more than the solids. Or, the solids can't compress, but the liquids can just slightly compress more than that. When having a look at the gases, they're highly compressible. Highly compressible. Compress is simply, pushing down or something like that. Okay, I'm sure you've got that. Like, for example, you have a can, you know, you smash it down, you're compressing the gas inside it. You're compressing it. Okay, that's basically what it means by compressible. Then we have a look at density. In terms of density, solids will have high density, liquids will have moderate to high density, and gases will have low density. So you can see from solids to gases, the density is decreasing as it goes down the path. Finally, we have a look at the aspect of flowing. That simply means that a solid cannot flow. Now, you can, compare this with like a liquid. Okay, for example, if I pour water down, it's gonna flow, right? If I pour liquid down, it's going to flow. But if a solid will not flow, it's just going to stay stationary at that place. If I drop an object, it's just going to stay there. But liquid will flow down. Okay. Same to gases, it will flow. So that was a very good table which I found, and you also need to know this for core and for the supplement. So these are the 5 rows that you must know, because sometimes in exam questions you're asked to tell the properties between solids, liquids, and gases. Now you can say any of these properties and you will get it correct. Now, as you guys can see, we're coming to something called the kinetic particle theory of matter. Matter, remember, is basically, made up of particles. Okay? It's made up of particles. These particles keep on moving due to the kinetic particle theory. The average kinetic energy of the particles is dependent on temperature. Now, later on, we're going to come to a chapter where we have a look at rates of reactions. Now, I've made a video on this, but again, because of this series, I will repeat all of those topics that I've done also in this channel before. So, it's simply like starting fresh. So, in this topic, what we look at is the factors that affect a rate of a reaction. Now, the kinetic particle theory is a very, very important theory which explains how reactions happen. That simply means that when I add temperature, okay, the particles will gain something we call kinetic energy. This kinetic energy will therefore result to more collisions between the particles, because remember, every object has particles. So when I introduce heat, for example, they're all going to react. The particles are going to react together. There will be more collisions. And when there are more collisions, we say there will be a faster rate of a reaction. Okay, so kinetic theory is all related to matter, because matter has particles and the kinetic theory talks about particles. Hopefully that made sense. But again, in the future videos where I will talk about rates of reaction, I will talk about the kinetic theory once again. So if you're confused right now, don't worry. But for now, you just need to know that all matter in this world, or anything that occupies space in this world, will have something we call particles. Okay, and then later on we will define what the kinetic theory means. Okay, let's move on to the next topic. The next topic, we're going to have a look at how the structure of the solids, liquids, and gases are different. And this, we will look at the EMA. The EMA simply means the energy, the movement, and the arrangement. So we're going to have a look at in terms of energy, we're going to have a look at it in terms of movement, and finally have a look at it in terms of arrangement. Now, also, so many questions talk about, describe the arrangement, describe the movement, describe energy. So you need to know this table also. We start with energy. Okay, let's start with energy. And you can see right here, it is saying that solids will have a low energy. That simply means, okay, when we're having a look at in terms of energy, when we're saying energy, we're simply basically meaning what it is capable of. What is it capable of? And you can see right here, it is saying that solids will have a lower energy compared to liquids and gases. Liquids will have higher than solids, and gases will be the highest. Now, usually in these questions, they just ask you, straightforward questions, okay? Like, describe in terms of energy, okay? You simply just say solids have a low energy, liquids have a higher energy, and then gases will have the most energy. Then, when we have a look at movement, movement is a very important, aspect when comparing these three, solids, liquids, and gases. In terms of movement, we say that solid particles can vibrate about fixed positions. Okay, that statement is tested a lot. Okay, particles can vibrate about fixed positions. For the liquids, the particles can slide over each other, move over each other, and can collide often. Okay, but they don't collide, a lot, but they collide often. With the gases, the particles move freely and randomly, and they collide much less. Okay, so that is it in terms of movement. So we've had a look at energy, we've had a look at movement. Now let's have a look at arrangement. When having a look at arrangement, the particles are closely packed together and they have a regular structure. Okay, the ordered arrangement is often called lattice, and again in the future topics, when we talk about the graphites, when we talk about diamonds, when we talk about all these structures, giant atomic structures, we will again discuss about lattice. So don't worry if you don't understand what lattice means, but right now you need to know that lattice simply just means the arrangement of the particles which it forms. Okay, that's basically called a lattice. For the liquids, the particles are loosely arranged. Okay, that means that compared to solids, they're not arranged in such a tight or packed way. Okay, they are, but loosely arranged. And for the gases, the particles are widely separated because, again, if we look back to the previous table, it is telling us that the gases, okay, the gases occupy as much space as possible. So we can back that answer by saying because the particles are widely separated from each other, okay, because they like to spread, okay. So we move on, and now this is just a simple diagram, okay, and it's quite familiar. I'm sure you've heard of this, so you've seen this um, diagram before. So you can see solids right here. They have a fixed position. They're tightly packed together, and they're regular. The liquids, they are, sort of there, while they are kind of regular, but not as regular as the solids. And then gases are just separated by each other. And remember here it's saying random movement. That means that when the particles move, it's random. Okay, there's a random movement between each other. We move on now to the third topic, or the fourth one. The fourth topic talks about describe the changes of the states in terms of heating, boiling, evaporating, freezing, and condensation and sublimation. So this is also a very common tested question. This basically topic talks about how something can change its state. How can water become ice? Okay, how can water become a gas? So in these reactions, we say there's a change in the state. Okay, so here we say that there are three common physical states of matter. Okay, and we know those are solid, liquids, and gases. Now here's a diagram that you need to know. Okay, it is saying that a gas to a solid is deposition. From a solid, okay, let's just show you. From a gas to a solid, it is deposition. Right here, deposition. From a solid to a gas, it is sublimation. And these ones, the other ones are quite common. Like from a solid to a liquid, we say it's melting. From a liquid to a solid, we say it's freezing. Then again, from a liquid to a gas, we say evaporation, and gas to liquid, condensation. It says right here, change of state from a liquid to a gas is termed as boiling or evaporation. Boiling takes, okay, so here's the difference between boiling and evaporation. Sometimes they ask you the difference between, what is the difference between boiling and evaporation? The answer would be boiling takes place at a fixed temperature. Okay, this is called the boiling point, while evaporation takes place over a range of temperatures. That is the difference between boiling and evaporation. But again, they are classified as the same. So if the exam, tells you to sort of, talk about liquid to gas, you can say boiling, you can also say evaporation. Then it says right here, for the IGCSE 0620 exams, change of states from gas to solid can be termed as sublimation. sublimation. So solid to gas can be termed as sublimation, and you would get that correct. Okay, move on to topic 5, and topic 5 talks about the heating and cooling curves, and this is for the people that do supplement. So if you do core, you don't need to know this. Again, remember, core is paper 3, supplement is paper 4, and that's how you can differentiate. So you can ask your teacher, if you're doing paper 3, you do not need to know this, but if you're doing paper 4, you do need to know this because this is sort of extended. Okay, so heating and cooling curves. A heating or cooling curve is simply a graph of temperature against time. As simple as that. Okay, they don't ask you what a heating or cooling curve is, but you need to know that simply it tells you the temperature against time. Okay, and the main reason we do these heating and cooling curves is to observe the state of a substance as it is heated or cooled. Okay, so here it's saying the sloping regions of a curve can depict in temperature but not in state. So the sloping region, so this sort of sloping region right here, okay, will depict that it will change in temperature but not in state. And the flat regions right here, like this, the flat regions basically says that there's a change in state but not in temperature. Okay, so quite self-explanatory because when it changes, then there's a change in temperature but not in the state. But when it's straight in a line, temperature is the same, but there's a change in time. Okay, so here we have a curve, the cooling curve for a substance. So you can see right here it's gas, okay? It gets condensed to a liquid. From a liquid, it freezes to become a solid. Remember, the straight lines is when the temperature is the same, but there is a change in state. So the change in state right here would be condensation. The change in state right here would be freezing. And right here, gas, liquid, and solid is the, the states of matter at that particular time, okay? Here we have a question now. The graph shows how the temperature of a substance changes as it is cooled over a period of 30 minutes. The substance is a gas at the start. So at the start right here, at S, right, it is E gas, of course, okay? It is E gas. And then it tells us each letter on the graph may be used once, more than once, or not at all. It says which letter, S, T, V, W, X, Y, or Z, shows when the particles of the substance have the most kinetic energy. Now again, let me explain kinetic energy once again. Kinetic energy simply means, okay, when I heat the most, okay, when I heat the most, the particles will vibrate more. The reason to this is because they gain something we call kinetic energy. These particles, as I told you previously, every matter has particles. And if I heat something, these particles will gain kinetic energy, and hence there will be more frequent collisions. There will be so much collisions, frequent collisions, that because of the kinetic theory, the reaction becomes faster. And my keyword right here is when there's high temperature. So that basically means that the kinetic energy, or when there will be most kinetic energy, is when there will be the most temperature. And therefore it should be S. The answer right here should be S. The next question says that the particles in the substance are the furthest apart. So again, when they are the furthest apart. When are they furthest apart? In the start. It's because the temperature has not yet got to them, okay? Because once when they start getting heated, they all will come together. They will because once when they get temperature, they all will gain kinetic energy, so they will collide more frequently because of the increase in temperature. So when will they be the furthest apart? They'll be the furthest apart when they will be in the start. So again, for this question, the answer is S. The next question says when the substance will exist as both a gas and a liquid. When will it occur as a gas and a liquid? So here we go back to the table. So you can see from S to T, it's still a gas. Okay, it's still a gas. Then from V, it should change something to here we say a liquid. Okay, so a liquid right here. Okay, so here it becomes a liquid. So right here at V, there's a change in the state. But right now, it's not yet fully changed. So that basically means that at V, the change of state is occurring, and therefore at V is when it will be both the exists as both the gas and a liquid. So the answer would be V. So the answer right here, as you guys can see, is SSV. And let's just have a look at the explanation. The explanation says that the order of energy from a gas to a solid would be gas, liquid, solid. The point S is where they have the highest energy. The gas particles can move randomly and are furthest apart. Yeah, that's correct. And then it says the higher the temperature, the greater the energy. And this is basically what the kinetic theory states about. This is what the kinetic theory tells us. Okay, let's move on and let's talk about another question. Okay, oh, this is more of the explanation, sorry. So as you guys can see, what I was talking about before, okay, the gas at S will have the highest energy. When I increase the temperature, they will collide more and will go down, change the state to become a liquid. So here at this point, it's a liquid. At this point, it's a solid. Here at G to W, it is changing the state, and from L to Y, it is changing the state. It then says, use the graph to estimate the freezing point of a substance. Okay, the freezing point of the substance. The freezing point simply states that when will it become a liquid to a solid. Okay, so when will it become a liquid to a solid? You just look here and you can see it's around 140 degrees, and therefore the answer will be 140 degrees. It then says name the change in state from a solid to a gas, and we have looked at it before also, and it was also telling us here that from where is it a solid gas, solid to a gas is sublimation. Okay, and also it's saying that for in the 0620 gas to solid is also called sublimation. So the answer will be sublimation right here, as you guys can see. Let's move on and let's talk about the change in states according to the kinetic theory. So now let's have a look at the kinetic theory. So right here we have a solid, we have a liquid, and we have a gas. And it's telling us that they are increasing the temperature and they're decreasing the temperature. When I increase the temperature, the solid will become a gas. When I decrease the temperature, the gas will become a solid. Okay, so that's a quite simple demonstration of what the kinetic theory means. Kinetic theory, again, I'm going to repeat, and I'm repeating this so many times that you should understand what kinetic theory means. And I hope that you understand what the kinetic theory means, because it's a very, very common question, and it's a very common topic that is tested. Kinetic theory is when I introduce heat to something, the particles will gain the kinetic energy, and the kinetic energy will result to more collisions, because remember, everything has matter and therefore everything has particles. So these particles will react together, more collisions will therefore result to a faster rate of the reaction, and therefore there will be a change in state. For example, a solid to a gas to a solid, solid to a liquid, liquid to a solid. Okay, depending on temperature. So the key factor right here is temperature. Later on, we're going to have a look at some other factors like pressure, surface area, catalyst. So we're going to have a look at all those factors in a later topic where we talk about rates of a reaction, and I've made a video on it. So if you want to watch it before I even make the video, you can feel free to do. Now I've done, I believe, a live stream on rates of a reaction, so you can go watch that to understand more about the different factors that affect the kinetic theory, and also we talked about the collision theory. So it's both the kinetic theory and the collision theory. So now let's have a look at the difference between the following. Okay, so these are the key terms that you need to know. We need to know the difference between melting and freezing, the difference between boiling and condensation, and therefore sort of those two. Okay, you need to know those two. So let's start with melting and the freezing. So let's start with melting. So melting, it says when a solid is heated, the particles will gain energy, okay, because of the kinetic theory, and therefore they will vibrate faster. So this sentence right here is just talking about kinetic theory. They push against each other, and the compact structure loosens up, and the arrangement starts to change the order to disorder. Okay, so because of the collisions, it will change the order, and it will melt. Okay, from, for example, a solid to a liquid. With freezing, it is the opposite of melting. When the liquid is cooled, okay, when I reduce the temperature, the particles will lose energy, and when they lose energy, the movements slow down. Therefore, they collide less frequently and they will come closer. When they become closer, the arrangement will change. Once the freezing point has been reached, the particles will change over to a solid and start vibrating at fixed positions. Remember, this is a property of a solid. Solid vibrates at a fixed position. Okay? We've talked about all of this in the previous tables. And then it says, note, melting point of a pure substance is the same thing as the freezing point. So melting point, freezing point is the same for a pure substance. Okay, we move on to the difference between boiling and condensation. When having a look at boiling and condensation, boiling is when the liquid is heated, so here is increasing the temperature, the particles will gain energy, will move faster, again because of kinetic theory, they will collide more frequently, will push against each other, okay? This will therefore, the heating is continued, the force of attraction between the particles weaken further, and the distance between the particles will increase. This therefore, at the boiling point, the particles will start to change over to a gas and they move randomly and their arrangement becomes highly disordered, because remember, that's a property of a gas. Okay, they are not in a fixed position. Okay, their arrangement is random. Okay, also particles move in a random movement. Okay, so you cannot determine where they will move, it's all random, in a random movement, and they just collide in a random sort of way. Then when we have a look at condensation, condensation is the reverse of boiling. So when a gas is cooled this time, so when you're decreasing temperature, the particles will lose energy. When they lose energy, there will be less collisions. When there's less collisions, the force of attractions will become stronger and the distance between the particles will decrease. The boiling point will be reached and therefore they will change to a liquid. And therefore that means that they will start moving over each other because that is a property of a liquid. So right here it says, describe the qualitative pressure and temperature of a gas in terms of motion of its particles. In a gas, the particles are relatively far apart, and we've discussed this in the previous tables. They are free to move anywhere within the container in which they are held. They move randomly at very high velocities. Also, it's telling us they collide with each other. You also need to know that they collide with the walls of the container, thereby creating pressure on the walls. Sometimes you have some questions saying that, when, why is there some pressure felt on the walls when, there's so many gas particles? This is because they collide with the gas, or they will, collide with each other, therefore hit the walls, and therefore they create a high pressure. At a higher temperature, the average kinetic energy of a particle will increase. They move faster and collide with the walls of the container more often. The increase in the pressure exerted by the container by the gas. Okay, so this is how there is an increase in the pressure because of increase in temperature. So you can see how everything is related to the kinetic energy. Now I've been saying this throughout the video, so I hope you understand kinetic energy. Okay, so kinetic energy is related to pressure too. Here we talk about the Brownian motion. Okay, so this is also for core. The Brownian motion was basically discovered by someone called Robert Brown, and he discovered this while he was studying the movement of pollen grains on the surface of water. Basically, what he saw is that the random motion of visible particles caused by much smaller invisible ones. This is what we call the Brownian motion. And then evidence of this is the kinetic particle theory. Okay, so right here is a diagram of what he saw or what he observed in the microscope. This is the Brownian motion that you see, okay? And he discovered this through the pollen grains on the surface of the water. He saw that they were moving or they were jiggling, okay? That's what he observed. And then he got to know, because of the kinetic particle theory, these movements are caused by much smaller invisible water particles, which we call the Brownian motion. Here it's saying, okay, we describe the Brownian motion in terms of the random molecular bombardment. Okay, as per Robert Brown, the pollen grains were moving because they had a smaller, invisible particle, and therefore, faster movement of water particles will constantly collide with them, which we call bombardment. Okay, so that's what the Brownian motion basically talks about. It's the bombardment of the invisible particles and the particles. Now these invisible particles, you can't see them, but with a microscope you can see them. Okay, and that's what the Brownian motion talks about. So here we have a question. It says, the dust particles in air move around in a random way. What term describes the random movement of the dust particles? The random movement is the Brownian motion. Because of the invisible particles and the particles, their actual particles, there will be a zigzag movement, and therefore there will be a random movement of the dust particles because of the Brownian motion. The next question says, explain why the dust particles move in this way. The dust particles will will collide more because of the larger air particles, which are much larger than the air particles. They will collide with the other air particles, and therefore they will move randomly. So it's all about bombardment. It's all about the collisions between each particle, and that's why they, separate, or that's why you know, the particles move all over in a random direction. Okay, so here's the diagram of something like that. The invisible particles are the ones that are small, and then that's the dust particle, which they collide each other and they move, separate. So you can see this smoke as seen in a smoke cell. So this is basically a microscope and how they are observing the different particles in relation to the small particle, which they collide with each other. And that's basically the Brownian motion. Here we look at diffusion. Diffusion is a very popular topic, and basically diffusion talks about the spreading of a gas. Okay, diffusion is the movement of a gas from an area of a higher concentration to an area of a lower concentration. Why do we say high concentration to a low concentration? That means, for example, in this picture, as you guys can see, someone is releasing gas. Let me not mention what gas that is, but basically they're releasing some gas. Okay, this gas at itself, at the person himself, is high concentrated, but as it spreads the gas will become low concentrated, and this is because of diffusion. Okay, so an example, diffusion of smoke through air. It is the process by which the different substances mix as a result of the random motions. Again, we've talked about the random motions because of the Brownian motion. Okay, so here we have some topics. Now let's have a look at the diffusion on the molar mass. Now usually in MCQ questions, they give you maybe two substances, okay? For example, chlorine and bromine, and they tell you why is this element, the diffusion rate is slower than this. Simply what you have to do is find something we call the MR, okay, the molecular mass. The molecular mass can be calculated from the periodic table. So if I go to the periodic table, I have to look at the mass of each. The heavier the mass, the slower the diffusion. Okay? The heavier the mass, the slower the diffusion. And the lighter the molecule, the faster the diffusion. That's what you really need to know. So it's saying when a chlorine gas is put into a gas jar, it will spread out to fill the gas jar. The bromine is put and it will spread out to fill the gas jar. But the process for bromine takes longer. It'll be longer for the bromine gas than the chlorine gas because bromine is heavier. Okay, here we have some questions. It's saying the process takes longer for bromine gas than chlorine gas. What term describes the way that the gas particles spread out? We say they spread out because of diffusion, and the explanation will be because the gaseous particles move from an area of high concentration to an area of low concentration, which we call diffusion. It says use the data from the periodic table to explain why bromine gas takes longer to fill the gas than chlorine. As I told you before, bromine gas is much more heavier. As we saw in the periodic table, you can see bromine is 80 while chlorine is 35.5. Because bromine is more heavier, it will therefore diffuse slower than chlorine. Okay, so the next question talks about explain why the increase in temperature will increase the rate of particles. This is because a higher temperature will result to the particles gaining a higher kinetic energy. Because they have a higher kinetic energy, there will be more frequent and successful collisions. The more frequent and successful collisions will therefore make the particles collide with each other and therefore they will spread out. Okay, so there you go, guys. That is done, and we have finished the entire topic related to the particular nature of matter. Hopefully you enjoyed this video, and there will be quite a lot of more chemistry videos. Not only will there be chemistry videos, there will be for physics, there will be for many other subjects. So do subscribe to this channel, put your notifications on so you can wait for the next chapter in this IGCSE Chemistry 0620 syllabus. Thank you for watching this video, and I'll see you in the next one.